Now that we have our equation written in graphing form, it makes it really easy to see the vertex. Remember, the vertex is h and k. H is whatever value is being subtracted, and in this case, the value that's being subtracted is a positive 5. Here's our k value. So 5, negative 2 is where the vertex is. And then our domain, we know this is going to be a parabola, and go ahead and put the vertex over 5 down 2. It opens upwards. The domain is parabolas. This parabola stretches forever to the left and forever to the right. All inputs would work. So x is all real numbers, or you could say it goes from negative infinity to positive infinity. And the range, we know our parabola opens upwards. So the y values start at negative 2 and go up from there. Y is greater than or equal to negative 2. And then I need to go ahead and graph some more points. And I know because of this 3, right, it's going ahead and it's being stretched vertically. So it's really kind of 3 times as steep. And I could go in and plug some points in. I could plug in 4 and 3 and see where those points are and go ahead and graph them. And I would find that as I go out 1 in each direction, I would go up 3 on each side. A little hard for me to be accurate with this stylus. And then I would go up 9 in each direction. So let's see, my points would be, I have 5, negative 2, right? I would have 4, 1, and 6, 1. The other points I could go ahead and graph are 3, and then it goes up 9 more, so 3, 10, and 7, 10. And then I could go ahead and graph those points and get a pretty accurate graph. Our first step is going to be to factor those first 2 terms. So we can pull out a negative 2, which is our leading coefficient here, because when we do completing the square, we want to have just an x squared. So we can rewrite this as negative 2 times x squared minus 2x. And then outside the parentheses, we're going to leave that plus 3. So now, when I complete the square, it's important to notice that it's going to be negative 2 times everything that I used to complete the square, and we've still got that plus 3 on the outside. So let's go ahead and set up that square. So you can see I've gone ahead and taken this x squared minus 2x. X squared is here. Split the minus 2x exactly in half, minus 1x here, minus 1x here. And by filling in the outsides of the square, I can clearly see that this needs to be a plus 1. But it's important that I keep this balanced. So I have negative 2 and this 1 that I added that wasn't there before. So really, that's a negative 2, because negative 2 times 1 is negative 2. And the way I'm going to keep that balanced is, since I put a negative 2 inside the square that wasn't there before, I'm going to go ahead and I'm going to add 2 on the outside. So negative 2 on the inside plus 2 on the outside. That will balance, keep our equation balanced. We haven't changed the value. So if I go ahead and simplify to write this into graphing form, I have y equals negative 2. I have my square, which is x minus 1 squared, and then the remaining value, which is plus 5. And now I have this in graphing form, and it makes it really easy for me to see the vertex, the domain, and the range, and then to go ahead and do the graph. So the vertex, the domain, and the range. The vertex, I can tell, since this is in graphing form, is going to be a positive 1 and a positive 5. So I know that this parabola, because there's a negative 2 out front, I know it opens downwards. So I can either go ahead and do the graph and then do domain and range, but even just knowing these basic parts, that this is at 1, 5, and it opens downwards, is going to allow me to do the domain and the range. The domain, right, this parabola is all real numbers, right? There are all the values to the left, all those values of x will work, all the positive values of x will work. The domain is all real numbers. The range, I can see that my parabola never goes above positive 5, so our y values are always less than or equal to positive 5. Let's go ahead and do the graph. So I've already put the vertex 1, 5 onto the coordinate grid. We know it's going to open downwards. That -2 tells us not only that it opens downwards, but it's also stretched vertically, or it's going to be a much steeper parabola. So to get a few more points, I could go ahead and plug 0 in for x. And when I simplify, I see that I get a y value of 3. And so we can go ahead and add that to our graph. And by symmetry, we know we're going to get another point on the other side. We can go ahead and plug in -1 to get another point as well. And so when we do that, we can find these 2 additional points, which gives us a really accurate graph. And then we can go ahead and draw in the rest of our parabola.